So our first presenter is Taras Zadvornyi from the R.E. Kivetsky Research Institute in Ukraine, and he'll be presenting on his talk titled Collagen Fiber Organization in Benign Prostatic Hyperplasia and Prostate Cancer.
Hello, everyone. 1 second, please. Can you see my presentation?
Yes, we can see your presentation.
Okay. Thank you for a chance to present my result, our investigation, our team. It's only first year's results, and we started near 6 months ago, but I think it's very interesting teamwork and result, and in future we plan work in this sphere more. But now, as you know, prostate cancer is the second most frequently diagnosed cancer, and the 5 leading cause of cancer death among men in 2020, and the molecular and cellular mechanism underlying the development of prostate cancer are not yet completely understood. And it is known that the tumor microenvironment play a key role in the progression of many neoplasms, including prostate cancer. And tumor microenvironment consists of tumor cells, tumor stromal cells like fibroblast, endothelial cells, or muscle cells, and immune cells like macrophage or lymphocytes. And second big component in the non-cellular components of the extracellular matrix, such as collagen, fibronectin, laminin, elastin, etc. And the main fibrillar component of extracellular matrix is collagen. According to the recent data, the morphology, representation, and organization of collagen fibers contribute to the formation of tumor microenvironment, and which stimulate tumor progression by increasing cell migration and polarization. In addition, the remodeling of collagen fibers is of great in determining the survival and growth of disseminated tumor cells, and those formation of metastasis. Our investigation aimed to study the quantitative indicator of the special organization of collagen in the tissue of benign and malignant prostate cancer glands. And as you can see on the slide, our work based on the study 60 tissue sample from 40 patients with prostate cancer and 20 patients with benign prostatic hyperplasia, who were treated at the National Cancer Institute, Kyiv, Ukraine, from 2015 to 2020 years. And determination of collagen in the tissue of benign and malignant neoplasm of the prostate glands was carried out by histochemical method. We used Mason trichrom staining, and for morphometric study of collagen fiber organization was performed using the MAJ and Puriline 4.0 beta version programs. And the second big block was studying MMP gene expression level and protein. We used histochemical methods, and studied collagenase A and B, and collagenase first, second, third type, and gelatinase A and B type. And we used bioinformatic open data source like Cambridge carcinoma of the prostate app with Cambridge dataset for study expression MMP genes level in prostate cancer tumor. And a few words about morphometric determination, special organization of collagen fibers. We used microphotographs of tumor cells after Masson's trichome staining, and you can see we used two different program module Curveline programs. First, it was CT classical model, and we work with colored microphoto for study alignment, again, collagen fibers. And second big block is work with after collagen fiber segregation in different graphic program like Photoshop of GIMP, and we segregated only collagen fibers and study length with strained and angle or orientation collagen fibers in CT-FIRE model, and the density of collagen fiber in the tissue was determined as the ratio of the number of collagen fibers measured using the ImageA program to the area obtained when we work with a CT-FIRE model. And you can see a representative micro photo after Masson trichome staining, and all collagen fibers was stained in green or light green colors, and other elements like cancer cells is red with black nuclei, or erythrocytes was yellow color. And as shown in the slide, prostate cancer tissue were characterized by a significantly smaller density and alignment of collagen fibers. And on the next step was to investigate individual collagen fibers parameters. It was found that the prostate cancer tissue were characterized by a significantly shorter and thicker collagen fibers compared to benign prostatic hyperplasia tissue. And furthermore, was found that in patients with benign prostatic hyperplasia, there is increased orientation collagen fiber, or second name, it's angle collagen fibers compared to a patient with prostate cancer. So in the next step, we analyze the level expression of collagenase and gelatinase genes in benign prostatic hyperplasia and prostate cancer tissue using open data source. And we used a Cambridge dataset because it's only one open source who present level expression gelatinase and collagenase in benign prostatic hyperplasia. It's BPH box plot, second prostate cancer PSA, and you can see CRP PSA box plot. It's cancer castration-resistant prostate cancer and the most aggressive form prostate cancer now. And as you why we study MNP, because it's a group of enzymes responsible for the collagen and other protein degradation in extracellular matrix, and this data demonstrate this the prostate cancer tissue was characterized by a significantly higher gene expression level MMP2, but lower MMP9 compared with benign prostatic hyperplasia. But it's only virtual data. What captation in real life and with protein with protein, and we use immunohistochemical methods, and as you can see, analysis of the result immunohistochemical study showed that the prostate cancer tissue was characterized by higher expression level of collagenizes, first and second type MMP or MMP1 and MMP2 in 40 and 30% respectively, compared with patient with prostate with benign prostatic hyperplasia. And moreover, MMP2 expression or gelatinase A type expression was higher in prostate cancer tissue compared with benign prostatic hyperplasia, and analysis of the results show that collagen fiber density and alignment was lower in the prostate cancer tissue compared to the benign prostatic hyperplasia tissue, and furthermore, collagen fibers in the prostate tissue are characterized by significantly lower value and lengths, as well a higher value as this, and compared to a similar indicator in the BPH. And obtained data indicate that higher change of collagen microarchitecture in prostate malignant neoplasm may be caused by dysregulation of expression of MMP. Thank you for attention.
Thank you so much for your presentation, Taraz. Now, to start off the questions, and as a reminder, if anyone has any questions, you can leave them in the chat or Q&A. But for the first question, do you know of the age range of the patients that you took the samples from? Since if during aging, are there any changes in the tumor microarchitecture in terms of the collagen proteins or structure? I think you're muted. Sorry.
Sorry. We present data that demonstrate about changed collagen structure, but from literature data, we know about change expression collagen first and fourth type, and sometimes change expression collagen second or third type. It's different changes in different malignant neoplasm, and but in prostate cancer, all data indicate about change expression only first and increase I think collagen first type, and about structure we think maybe MMP's activity or collagen structure change, because after activation MMP and other proteins like lysyl oxidase or high expression osteopontin, its our preview results change structure collagen, and after remodeling, after this change, after remodeling extracellular matrix, prostate cancer may be more metastatic activity, and for clinic it's will be a good idea if we used like automatical detection system for collagen collagen structure with artificial intelligence, and like very good instrument in prostate cancer, not only diagnostic but prognostic marker.